Hello everyone, welcome back to my organic mechanism talk. And just as usual, I always want to remind you that arrow position always shows the movement of electrons in organic reactions. Today we will talk about the dehydration of alcohols, and we will talk about different ways to dehydrate the alcohol. The first, or also the most common way, is catalyzed by acid, and I use the example of cyclopentanol and reaction give you the cyclopentene. The catalyst is the sulfuric acid, and the reaction needs heat. And the mechanism of this reaction will always start with the first step is activation of this alcohol, just by protonation. So this arrow from the lone pair of the oxygen to the proton, and then break the hydrogen-oxygen bond. So this step is called a protonation to convert the hydroxyl group to water. So water is a much better living group than hydroxide. And then the carbon-oxygen bond will be dissociated and then form a secondary alcohol, a secondary carbocation. The proton, this proton is called a beta proton, will be deprotonated by a base, and then electrons between carbon and hydrogen will push back to form the double bond to form the product, cyclopentene. This mechanism is more like a E1 elimination mechanism. So, and this is the general mechanism for secondary alcohol or tertiary alcohol. For primary alcohol, actually, although the reaction also gives the alkene as a product, condition is the same, but the mechanism will be different, will be more like E2 type mechanism. So I will use the example of this 1-propanol, and the first step is also protonation. That's the same. And then the hydroxyl group will be converted to a better living group, water. Now, the base can deprotonate the beta proton, and the electrons between the hydrogen carbon will push back and kick off the living group, and then form the product. That's propene. And then this is more like a E2 elimination mechanism. And for the primary alcohol, actually, there's a side reaction could happen is this intermediate with the water as living group can actually be attacked by another molecule of alcohol. The lone pair of the oxygen can actually attack this carbon and kick off the living group to form a protonated ether as intermediate. This proton can be removed by a base by deprotonation, and then the product will be a neutral ether. This is actually dipropyl ether. So that is another possible product. So for this primary alcohol, you could have 2 products. Okay, this is the way, most common way to dehydrate alcohol, just catalyzed by acid. Another way to dehydrate alcohol is actually via sulfonate. So basically, the alcohol can be converted to OTS as a much better living group, and then the base can eliminate this intermediate to form the alkene as final product. So this is another way. Now let's look at the mechanism. First, the alcohol will react with a TSCl. It's called a tosyl chloride. So basically, it's a p-toluene sulfonyl chloride. And then the oxygen's lone pair again attack the sulfur, break the sulfur-oxygen pi bond to form this intermediate. And then the oxide will push back to kick off the living group, the chlorine, and then form this protonated intermediate. And then the base will deprotonate this proton and form the neutral intermediate. This is a sulfonate. And then this group is the leaving group. This is called OTS. So it's exactly the same as this OTS. And OTS is a very good leaving group. So this beta proton can be deprotonated by the base. The second step is the methoxide. It's the strong base. And that will push the electron between the carbon hydrogen to here to form the double bond and kick off the leaving group to form the cyclopentene as the final product. So this is the second way to do the dehydration. The way to do the dehydration is by another reagent. It's called phosphorus oxychloride. And this is a mild condition because the temperature is low. And so we can see this reaction's mechanism step by step. First, this alcohol react with this phosphoric oxychloride. Oxygen's lone pair attack this phosphorus, break the pi bond, and then form the intermediate. The oxide will push back to kick off one of the chlorine as leaving group to form this intermediate. And then this beta proton will be deprotonated by pyridine. The pyridine is the base. So the pyridine will take this proton, and then the electron between carbon hydrogen will push back to form a pi bond and also kick off this big leaving group, which is also a good leaving group, to form the product cyclopentene. So this is the third way to dehydrate alcohol. Of course, I think there are more ways to do this, but so far we can talk about this three methods. Okay, so if you have any questions, just let me know. Okay, good luck.